Hello guys, so welcome to your channel which is Sci Engineers. This is Sushant. We had uploaded videos for your first order differential equations, how to solve the various first order differential equations, the various methods for it like linear differential equation, Bernoulli's differential equation, exact differential equations and many more like this. So if you're new to the channel, you can just go and watch them in the playlist for your Applied Mathematics 2. If you want to watch the videos for your Applied Mathematics 1 subject, then you can do so in the playlist for the same. We have already uploaded videos for your engineering mechanics and basic electrical engineering, so you can go and watch those videos also. To get the regular updates, you need to just subscribe to our channel, like our videos and share it with your friends. Your sharing and liking of the videos will help us make more videos for you guys. Do write in the comment section what more videos you would like us to make on and how do you find these videos. So today's topic will be the wrapping up of your first order, first degree differential equations, how to solve the equations in general cases. So let's get going. So whenever you are encountering a problem which is going to be your first order, first degree differential equation, first of all you have to identify which type of differential equation it is. So the first thing is that you have to identify whether it is your first order, first degree. So that depends on the differential equation having the first order and it should have the first degree. That means it should be only a dy by dx term or the dx by dy term present in that particular equation. If that is satisfied, then the priority is given first to the exact differential equation. That is, you have to check for your dou m by dou y is equal to dou n by dou x. If that is satisfying, then you can go and solve the equation depending on the exact differential equation. If the equation is not going to be an exact differential equation, then the next priority is given to your linear differential equation. So we have already discussed how to identify the linear differential equation. So you can just go and watch those videos which we have. The link for all the videos related to this particular topic is given in the description below. The next priority which is given is to the reducible to linear differential equation, which are of the form of f dash of y into dy by dx plus f of y into p is equal to q form. So if it is in this form, then you will be solving accordingly. Then the next priority after this is given to your Bernoulli's equation. If that is not solving, then at the end you go for the solving of the rules. So the rules are nothing but those rules which reduce down your differential equation into your exact differential equation. So let's see some sums and how to identify the given equation, whether it's going to be the linear exact or whether we have to apply the rules. So let's have a look at this particular problem. So we have a y by x sec y minus tan y dx minus x minus sec y into log x dy is equal to 0. So as you can see that it is already in the terms of your m dx plus n dy. So the first step what you have to do is you have to check for your exact differential equation. That is a condition for exact differential equation, that is dou m by dou y. So that's partial differentiation of this with respect to y. So from this you will be having the 1 by x common into the derivative of y into sec y. So it's going to be sec y plus y into sec y tan y. And it's going to be the minus of tan y. So minus tan y's derivative is going to be nothing but your sec square y. So this is your dou m by dou y. Then coming to dou n by dou x, that is derivative of this with respect to x. So you can see that your n is nothing but minus of this term. So when you are taking the derivative of it, it's going to be minus 1. It's going to be plus sec y into log's derivative is 1 by x, and that's it. When you're comparing these two terms, you can see that they are not equal to each other. So basically you are getting this equation is your non-exact differential equation. So once you are getting that it is a non-exact differential equation, then you have to go for the next thing, that is checking whether it's going to be in the form of your linear differential equation or not. So when you're checking for linear differential equation, It's quite complicated to find whether it's going to be a linear differential equation or not, because if you can just recollect, your linear differential equation is dy by dx plus p into y is equal to q, or the other form is your dx by dy plus p into x is equal to q. So you can see from this you require only y or only x term. So you can see that we have combination of x and y's, the functions of x and y. We don't have a single y or a single x present in this. So it's obviously not coming as your linear differential equation. Then the next priority is seeing whether the function is present. Again, using the same logic, you are having that you can see that there is nothing like a derivative of some term which is present in some other term. So it's not of that form also. So first we are checking out for the first rule because we are not getting the equation as exact. So after substitution of dou m by dou y minus dou n by dou x, we are getting something like this. So we can see that these terms gets cancelled out. From this, if we take the sec y term common, or basically what we can do is we have a minus sign common. So we can write this as a sec square minus sec square y minus 1. So that becomes a tan square y. So replacing this part with a tan square y, if we are taking the tan outside, what you can see is that it is not getting cancelled out with this part, and it is not reducing down to a function of x only. So obviously this particular rule has failed. So going for the second rule, when we are observing the second rule, we have the dou n by dou x minus dou m by dou y. When we are checking out the terms, we can see that this gets cancelled out. Then again with the same thing, that is sec square y minus 1 becomes a tan square y. So this will be replaced by a tan square y. So again if we take the tan common from here, so you'll be landing up with this as, let us say we are taking the tan y common. So we'll be having a minus y by x sec y plus tan y. And if from the denominator we are taking the minus 1 common, so that becomes a minus y by x sec y and plus tan y. So basically this particular term gets cancelled and we are landing up with a function which is tan y. So this is nothing but your f of y. So this particular rule is applicable. So then we will be following the steps, that is you have to find the integrating factor for this. So we had found out our f of y which is minus tan y. So your integrating factor is nothing but e raised to integration of f of y dy. So that is e raised to integration of minus tan y. So we know that tan y's derivative, so we know that tan y's integration is nothing but a log of sec y, or it can be a minus log cos y. So the minus minus gets cancelled out and we are having a e raised to log cos y, which is nothing but cos y. So we have found our integrating factor. Then after that we have to simply multiply this integrating factor with this particular equation and we will be landing up with a exact differential equation. So the solution will be directly written as, so you have to keep in mind that we are multiplying this cos y throughout this equation and that is going to be the exact differential equation, and we are finding the solution as going to be integration of, we'll be having a y by x into sec y into cos y. So basically the sec y gets cancelled out. So we'll be having a y by x minus a tan y into cos y gives us a sin y. So it's going to be a sin y present over there. This integration you have to remember that we are taking the y as a constant term. So we'll be integrating accordingly. Then it's going to be the integration of this. So we have a minus sign outside, so we'll be having a minus over here. It's going to be integration of a cos y into this. You have to keep in mind that in this particular integration we do not want any x terms. So you can see that there is a x term into cos y, so basically we'll be not taking that. We have a sec y into log x into cos y, so sec y gets cancelled out, but we still are remaining with a log x. So basically this integration will be nothing but integration of 0 dy and this will be equal to c. So we are landing up with just finding the integration of this. From this y is constant, so y will come outside. So its integration is 1 upon x, which is going to be log x, minus sin y is also constant, and integration of dx, which is x, is equal to c. So we are landing up with this particular equation, which is your solution for this differential equation. So let's have a look at one more problem, which is going to be related. So let's have a look at this particular problem. So we have a dy by dx is equal to y cube upon e raised to 2x plus y square. Now in this we can just simply check out that this particular equation is not your exact differential equation by just simply cross multiplying and checking out your dou m by dou y and your dou n by dou x term. You will not get it equal, so it's not going to be an exact differential equation. So coming to the next step, that is whether it's going to be a linear differential equation or not. Now when you are having a linear differential equation, you have to remember that it should be either in the form of dy by dx plus py is equal to q, or it will be your dx by dy plus px is equal to q form. So let's try to manipulate certain things over here. If we are just keeping it dy by dx, we are not going to have it in the form which is required. So let us see if we reverse it, what is going to happen. So if we write it as dx by dy, it's nothing but the reciprocal of this. It will be e raised to 2x plus y square upon y cube. So still it is not landing up with your linear differential equation even when we split it up. So after splitting it up, what you can observe is that this becomes e raised to 2x upon y cube, and this will be a plus 1 by y. So from this what you observe is that it is no longer in your linear differential equation form. So let us check for the next criteria, that is whether it is reducible down to linear differential equation or not. So for that what you require is, you require with the dx by dy a derivative of a function which is going to be present along with your p. The p and the q in that is going to be functions of y only, and the function which is going to be present with your dx by dy should be function of x. So you see that there is only one function of x, but we can manipulate it by dividing the entire equation by e raised to 2x. So when you are dividing the entire equation by e raised to 2x, you will be landing up with something like this, that is e raised to minus 2x dx by dy, and in this also e raised to minus 2x by y. So after this what you can simply do is rearranging the terms. You will be having this as e raised to minus 2x into 1 by y is equal to 1 by y cube. So you can now see that you are having the function of x. In a way you are having a derivative of it along with your dx by dy. You are having the functions of y in the place of p and q. So let's go for the substitution method. So substitution method is going to be nothing but we will be substituting v as e raised to minus 2x. When we are substituting this, we will be differentiating this with respect to y, because now y is the independent variable. So we'll be having the dv by dx, dy is equal to e raised to minus 2x into minus 2 dx by dy. So you can see that along with dx by dy we only have e raised to minus 2x. So basically we have to take this minus 2 on the other side. So substituting, and we will be getting the differential equation as this particular will be reduced down to a minus 1 by 2 dv by dy. This particular term will be nothing but your v term. So after this what you have to do is you need to just multiply throughout by a minus 2, because your coefficient of the differential term should be 1. So we have landed to this particular equation, which is now a linear differential equation. So we have reduced down our differential equation in the terms of your linear differential equation, which is in terms of v. So solving for that, we need to first find the integrating factor. We can see that your p term over here is nothing but a 2 by y. So we'll be finding the integrating factor as integrating factor is equal to e raised to integration of p dy. So it's going to be 2 integration 1 by y. So it's nothing but 2 of log y. So that is nothing but going to be y square. So when you're finding the integrating factor, after that you can go for the solution part. So the solution will be given as v into the integrating factor is equal to integration of the integrating factor into the q term. So that is your minus 2 by y cube dy plus c. So from this you can now substitute or resubstitute your v term. So v was your e raised to minus 2x. Y square is equal to, you can see that y square gets cancelled out with the y cube term. So only one y is left in the denominator. When you are taking the integration of it, it's going to be minus 2 log y plus c. So this becomes a solution for the differential equation. So let's have a look at one more problem which will be related to your first order, first degree differential equation. So coming to the next question, which is your dy by dx is equal to in this term. So coming for the first step, which is finding whether it is going to be an exact differential equation or not. So for that you need to just cross multiply this. So after cross multiplying you will be getting the term and then rearranging in the terms of m dx plus n dy. So you'll be getting the term which I'm going to write it directly as your tan y minus 2x y minus y dx minus of x square minus x tan square y plus sec square y dy is equal to 0. So we'll be having this as m and this as n. So we'll be finding your dou m by dou y. So you'll be getting this as sec square y minus 2x minus 1, which you can just reduce down by sec square y minus 1 is nothing but your tan square y minus 2x. Coming to this, that is dou n by dou x. So that is going to be minus 2x. It's going to be a minus tan square y and derivative of sec square y is going to be. So when you're comparing both of these, you will be getting that this is equal to this. So basically this differential equation is nothing but an exact differential equation. So directly going for the solution part. So the solution will be given by integration of the m with keeping your y constant. So that is going to be your tan y minus 2xy minus y dx minus, coming to this, we do not require any x term in it. So this term is gone, this term is gone, so only term which is remaining is this. So it's going to be integration of sec square y dy is equal to some constant c. Now in this we are keeping the y constant, so your tan y is constant, so it will be outside and it's going to be integration of dx, which is x. In this your 2y is constant, so your minus 2y will be outside, and your integration of x, which is x square by 2. Keeping the same thing, you will be having this as minus yx. For this you are having a minus x square y, which is nothing but tan y is equal to c. So on solving this, you will be getting the differential equation which is of this form. So do let us know in the comment section how do you find these videos, whether it is helping you in your preparation or not. Do share our videos with your friends and do like our videos. The liking and the sharing of our videos will help us make more videos for you guys. So we are associated with the Samartha Vidya classes, which is group tuitions for the engineering and science students. We have been helping students for the preparation for the first year and second year of engineering. So if you want to know about us, you can just email us at samarthavidya@gmail.com. The email address and the link for our Facebook page is given in the description below. So if you want to inquire about our KT batches, you can do so by emailing us at samarthavidya@gmail.com. We conduct the regular batches, vacation batches, and also the KT special batches. So for now, keep learning, keep watching, and happy learning. Bye.